Okay, so let's look at this question here. WASSCE June 2022, question 11a. The volume of a spherical balloon increases at the rate of 8 centimeter cube per second. Find the rate at which the surface area increases when the radius is 4 centimeters. All right, so let's try and solve this question based on rate of change. So he said the volume of a spherical balloon increases at a rate of what? 8 centimeter cube per second. So this is the volume increases at this rate. So this is what? The volume with respect to time. That is 8 centimeter cube per second. Okay, so divide t with respect to time. All right. Find the rate at which the surface area increases when the radius is 4 centimeters. Okay, so we are given radius as what? As 4 centimeters. So we are going to find the rate at which what? The area increases when the radius is 4 centimeters. Alright, so we are finding the rate of increase in the area. The volume of the sphere increases with respect to time. So if you are finding we are finding the surface area will also increase with the same respect to time. Then let's write our formula down and then let's see what we are supposed to do. All right, so let's say the area is what we are using a. All right, so that will be the a on what? The t. The area with respect to time. The area with respect to time. Okay, so the a dt will be equal to what? The a on, please take note, when we are finding the rate of change of the area. Okay, we cannot find the rate of the change of the area with respect to the volume. We have to use the rate of change of the area with respect to what? With respect to the radius. Okay, though what is giving the question is the volume with time, but what we have to do now is what? Find the area, because the area may change due to the change in the radius. Okay, the area will change due to the change in the radius, because the radius is a part of the what? Of the area. So when I want to look at the area of a sphere, okay, or the volume of a sphere, it involves the radius. The area doesn't involve the volume. Neither the volume involves the area. Okay, so the area is in the formula involves the radius. So when you are finding the change of the area, you have to find respect to the radius, not the volume. So it will come with respect to what? The radius, since I have the radius, times, okay, the change in the radius with respect to time here. So this is how our formula is going to be. Alright, the rate of change, since you are finding the area respect to radius, times the rate of change in radius with respect to what? With respect to the time. So we have to look for the rate of change of the radius with respect to time, and then the radius, the area with respect to the radius, before we can find the area with respect to time. Okay, so let's continue. So now we are going to find the a over the r and the r over the t. Okay, so what will be our area with respect to what? Our radius. So we now find the area of what? Of a sphere. Okay, so area of a sphere is what? 4 pi r squared. So this is area of a sphere. Then I can find what? The a on the r. So what will be my dA? That will be 8 pi r. So 2 come to be 8 minus 1. Alright, so 8 pi r. So we have gotten our dA on the r, the area respect to the radius. We have put it down. Then we now come to find the r on the t. So you see, we were not given the radius with respect to time, but we can find the radius from the volume. Alright, that's why the volume is given. So this can be what? The radius with respect to the volume, since I was given the volume, times the volume with respect to the time. Okay, so the radius with respect to time can be the radius with respect to the volume times the volume with respect to the time. Okay, so we can also use this one to find what? To find the rate of change in the radius with respect to what? With respect to time. Is that okay? I believe you get it. Okay. Then we have to find the R on the V. So the volume with respect to time. So we have to find the formula for the volume. So what is the formula for volume of a sphere? 4/3 pi r cubed. Then it implies that my dv on the r, dv on the r, we're going to be 3 will go here, then to be 4 pi r squared. All right, 4 pi r squared. So 3 times 4/3 will be 4. Then you subtract 1 from it, so 4 pi r squared. I believe you get it. Okay. However, we are supposed to find what? The r on the v, not the v on the r. So what we are going to do is to what? Is to you can see that our dv, the r on, therefore our the r on the v, okay, is equal to 1 over you reciprocate 4 pi r squared. So if the v on the r is 4 pi r squared, then the r on the v is 1 over 4 pi r squared. I believe this is so simple to understand. Okay. Then we have been able to, so one, we have gotten this down, and then the r on the t, that is what we are still on. So the r on the t, you have gotten the r on the v down. So what is left with the v on the t? That is what is here. The v on the t. So we have our v on the t here. So we can now conclude and write our answer. All right. Therefore, what can we say? Our main thing we are finding the a on the t, the rate of change is area, okay, with respect to time is going to be, say the a on the r. What is the a on the r? 8 pi r times the r on the t. What is the r on the t? The r over the v. What is the r over the v? That is 1 over 4 pi r square times times what again? The v on the t. What is the v on the t? 8. Okay, 8. So it's just substitution. It's so simple. The a over the t is the a over the r. That's the a over the r. This one times the r on the t. But the r on the t is what? The r on the v. That is 1 over 4 pi r squared times the v on the t. That is 8 centimeters. Okay. So what are we going to get now? Okay. So if you mean to multiply the numerator, 8 times pi times r times 8. 8 times 1 times 8 will give you 64. 8. Then 64, we have what? Times pi, then times r times 1. Okay. Then this will give you 4 pi r squared. So this is what we can have. Alright. Okay. So 8 times pi times r. 8 pi r times 8. 8 is 64. So 4 goes into 64 how many times? So 4 goes into 64, that will be 16. 16. Then pi will cancel pi. Alright. Okay. Then we have, here is r squared. So this r will take 1 from it. So we have 16 on r. But what is our r? Or are we giving our r is 4? So we are going to have 16 on 4. And that is 4. Alright. So our answer is going to be 4. We have found the rate of change in area in respect to what? Time. So area will be what? Okay, so 16 over 4 is 4. So we can, let me add a unit. Okay. So our answer is good. We have found the rate of change area in respect to time. So we can conclude that therefore our dA on the t is equal to our area. Area is this is in centimeters, so area is centimeter squared. And respect to what? With respect to time. So centimeter square per second. So the rate of change in the area, okay, is 4 centimeter squared per second. 4 centimeter squared per second. I believe you get it. This is so easy to solve, and I know we will meet again in our next lesson. Make sure to subscribe and share. Bye bye.